The chapters assigned for this module cover data and databases. Businesses of all sizes face issues with data. Whether it's tracking customer transactions, inventory, or maintaining information mandated by the government, the amount of data that companies must deal with is massive, and it can create problems. Well, we mentioned that managing data can be a problem, and here's some specific difficulties that companies face when they're managing their data. First off, the amount of data that companies have to deal with increases exponentially over time. The amount of customers that an organization has, the amount of sales and orders that those particular customers have, of course, is going to increase. We may have data scattered throughout the organization. The marketing department may have some data they're maintaining. The production department may have other data. And so it's a challenge to kind of put all that data together. There's new sources of data being developed all the time, big data, which we're going to talk about in this chapter. Data also degrades over time, and what we mean by that is people move, they change their address, companies go out of business, and so data must be maintained. It must be maintained accurately over time. And these are just some of the difficulties that organizations face. Even though we haven't gotten too far in this class, you've probably guessed that information systems are going to be able to help customers manage their data. One very useful tool the company can employ is called a database management system. Now, a database management system is a program that is used to create and administer a database. Now, some examples that you might have heard of are Oracle, Microsoft SQL Server, MySQL, and Microsoft Access. A database management system is not a database. It manages databases, so it allows us to create databases, and we'll explain a little bit more as we continue. So let's start with some definitions. The first is the word database. Now, a database is an organized collection of data. In theory, it would not have to rely on an information system. A Rolodex file, a phone book that nobody uses anymore would also be considered a database. But from an information standpoint, a database is going to consist of tables, relationships, and metadata. And we're going to explain those as we go here. All right, it's time to define some of the terms I've used, and one of the best ways to do that is to look at a database hierarchy. And we're going to start small and work our way into the larger aspect of a database. So the first element of a database is a field, and a field is simply a piece of information. That might be a last name or a first name, but that would be a field. Now, if you put all the fields pertaining to one particular person, such as an employee or a student, all those fields together, once they're filled in, become that individual or that entity's record. Now, within a database, a table is going to be a collection of records. So, for instance, I might have a table called employees. In the table called employees, I would expect to find all my employee records. I wouldn't expect to find a customer in the table called employees. Now, the database, as we defined earlier, is a collection of tables, which we just defined, and the relationship among the tables and metadata. And we'll go ahead and talk about relationships and metadata here in the next few slides. Well, let's start with a visual explanation of a field. Here we actually have an Access database and a form created in Access, and you can see that there are blanks on this form. There's a blank for first name, last name, student ID, and so each one of these blanks would represent the field within the database. You may recall that we defined a record as a collection of related fields and that they're all related to the same individual, same entity, same whatever you're tracking. So this is an example of a record. Here we have John Doe's record. So we have his name, we have his address. All the fields that we're storing about John Doe become John Doe's record. Remember, the table holds records. And so using the example from the previous slide, all the students in this database would be stored in a students table. But here we see an example of the attendance table. And so we have information about attendance records, and all of the records in this table have the same field. So a table stores records. In our discussion of the database hierarchy, we defined a database as a collection of tables. And here we see a list of all the tables that are in the students database that we've been looking at visually here. So we have a table for filters, guardians, settings, student attendance, students and guardians. Another term that we threw out previously was metadata. And metadata is data that describes the data in the database. It seems a little bit confusing, but metadata simply says, okay, we have a first name field, we have a last name field, we have an address. It is descriptions also telling us what might go into a particular field. It's not the data itself, but it's simply the names and descriptions of the fields within the database. Here we see visual representation of metadata. We don't see the actual first names that we're storing, but we just see the field names, first name, last name, and so on. We also have the data type, what kind of information is stored in each of those fields, and then in some cases a description letting us know what that field called first name actually stores. Sometimes it's obvious though. You may recall we defined a database as a collection of tables, metadata, and relationships. Here you see a visual description of a database relationship. In a relational database management system, the database contains relationships. Now, relationships are links between the tables that are related in some way. So in this example, you can see a link between the student table and the student attendance table. You can also see that there is a link between the students table and the guardians table. So one of the questions you might be asking yourself right now is, what's the big deal about database relationships? Why do we want them? Well, there are several reasons why we want to create relationships within our database. First, separating information into a separate table minimizes redundancy. With the previous slide as an example, let's assume that instead of having a separate guardians table, we created fields within the student table for guardian information. Well, that would work fine for only one student. But if, for instance, a parent or a guardian had more than one student at the school, we would end up having to type in their complete information for every student associated with that parent. By creating a separate guardians table, we would only have to enter that parent's information once. Then you simply type the guardian's ID into the student record. Of course, we'd have to have a field for that, and that would create a link between the individual student and the parent. We enter the parent information only once, not every time for each child they might have in the school. Eliminating redundancy also improves database accuracy. If we had one parent's information entered separately into 5 different student records, we might not get all of those updated if their address or phone number were to change. By relating tables, we could change the parent information once in the guardians table, and because we've only included a link to that table in the students table, then that information would be automatically accurate for all children if we were to make any changes in the one time that the parent information occurred in the parents table. A database application is different than a database. A database application is a database that has a user interface built into it. For example, an application would include forms and would often also include buttons that a user could click on, or a link a user could click on to get to a different form or use a specific report. Using only a database would require that the user would create a new form or a new report every time he or she wanted to see specific information in the database. A database application makes a database user-friendly. If, for instance, you use Blackboard or QuickBooks or even YouTube, you're really using a database application. In the world of business, especially when you're dealing with information systems, big data is also something you should be familiar with. Big data, as the term implies, includes massive amounts of data. And as this chart on the slide shows, big data might include information from your own organization, but it will also include data from other sources like government data, transactions on Facebook, what's trending today, what are people searching for on Google, sensor data, Amazon transactions. All of that would be examples of big data. Big data is so large, so massive, such large amount of data that it can't be managed by traditional database management systems. Big data might be structured like a list of transactions and orders placed in Amazon, but it could also be unstructured like Facebook posts or tweets or Google searches. And big data is used to predict patterns or trends, and it's very useful in marketing or other types of research.